Over the last decade, the adoption of solar PV DERs has seen tremendous growth. In fact, solar PV systems have seen an average of 42% annual capacity growth since 2006. Therefore, it is important to analyze and simulate the impact of solar PV DERs on the electric power system. The power system industry uses steady-state and dynamic simulations to study the impact of solar PVs on the power system at different time resolutions. Static PV DER models are used in steady-state power flow analysis by simulating snapshots of the system states with time steps in range of minutes up to an hour, which is sufficient for slowly varying states and low PV penetration levels. However, for higher PV penetration levels, utilities are more concerned about dynamic behavior. Aggregated dynamic models of PV systems such as PVD1 or DERA have been introduced for RMS positive sequence transient stability tools like PSSC and PSLF. These models attempt to represent the aggregated response of downstream PV systems but may not fully capture the impact of different voltage profiles across the distribution system. Now, these issues can be resolved using detailed dynamic models like electromagnetic transient or EMT models. Detailed dynamic models allow us to represent individual DERs or a group of DERs located at the distribution node. This allows us to capture the interaction between different DERs, the impact of unbalanced system fault, and the response of DERs to varying levels of abnormal system conditions. But the large computational burden involved with EMT models limit the analysis to only small networks. Therefore, we developed a PVDER simulation utility that uses dynamic phasor models, which are computationally more efficient compared to EMT models, and allows detailed modeling of individual DERs for large-scale transmission distribution systems. Created by Argonne National Laboratory with support from the Advanced Grid Research and Development Division at the Department of Energy's Office of Electricity, the PVDER simulation utility is a Python-based open-source tool to simulate individual PVDERs connected to the power distribution system. Using PVDER, you can model various types of single-phase and three-phase PVDERs. PVDER simulation utility is compatible with IEEE 1547-2018 standard and allows the user to implement smart inverter features like low and high voltage write-through logic as well as Volt-Var control. In PVDER, you can initialize the model with steady-state values and then introduce solar insolation and grid voltage and frequency change events. Using PVDER, you can develop a model, run a simulation, and visualize the results in a standalone mode with internal grid voltage source, or run a simulation in loop mode where grid voltage is supplied every time step by a third-party program. PVDER also allows you to customize the model by providing access to its parameters through a JSON file. PVDER simulation utility is Python-based and it is compatible with various power system simulators like TD-CoSim and OpenDSS. TD-CoSim and PVDER simulation utility are available as open source Python packages from GitHub. Here are some useful links to our GitHub repository where you can find detailed installation instructions and a user manual. More details about internal workings of PVDER simulation utility are published in the following IEEE article. If you have any questions related to PVDER simulation utility or TD-CoSim at large, feel free to contact us at support.tdcosim@anl.gov. Thank you.